Alright guys, this is going to be your 4-1 through 4-3 quiz review. Make sure you watch this, watch it as much as you need to prepare for the quiz tomorrow. On this first two problems right here, it says solve this triangle round, side lengths to the nearest tenth, and angle measures to the nearest degree. Alright, so we have this side right here is S, and we have R. We need to find S and R. Alright, so first we're going to use the angle measure that we have, which is 23. We're going to identify this side as opposite, and this side as the hypotenuse, That's the longest side, so it's the hypotenuse. And what we're going to do is we're going to use this side, which is 35, the adjacent side, to identify the values we need. So for this side right here, R, alright, we're going to say this is opposite and adjacent, so that would be the tangent identity. So tangent of theta equals opposite, which is R, over adjacent, which is 35. Alright, well we know theta is 23 degrees. So what we're going to do is multiply by 35 on both sides. Alright, right here. And what you end up with is 14.9. Alright, and now for S, we have the hypotenuse. We're looking for S as the hypotenuse, and we have the adjacent side. So adjacent and hypotenuse is cosine. So cosine of 23 equals adjacent over the hypotenuse. Alright, and what we're going to do is multiply by S on both sides and divide by cosine of 23. So we have S equals 35 divided by cosine of 23. And when we do that, we get a side measure of 38. It's 38.02, but 38. All right, because we got to round to the nearest 10. So 38, we know what this is. And now, lastly, we just got to find this missing angle right here. So if you remember, for a triangle, you must have the sum of 180 degrees. Well, this is 90. That will be 90 plus this will give me 180. All right, so these two angles will equal 90 degrees right here. That's already 90. So if I do 90 minus 23, that gives me 67. So this angle right here, angle T, is 67 degrees. All right, so that is how you do number 1. All right, for example 2 here, we need to find K, angle J, and angle L, and they gave us two side lengths. All right, I'm going to find the angle L first. And for angle L, this would be opposite, and this would be adjacent. So what we do is, which trig identity is opposite over adjacent? That is tangent. So tangent of theta, or L, equals opposite over adjacent. But remember, you can't find the tangent of L, all right? And you calculate it. So what we're going to do is use the inverse. If you remember the inverse of tangent. So L equals tangent inverse of 8 over 11. All right, and when we punch that in, we get an angle measure of 36 degrees. All right, and then now that we have that 36 degrees, we can find this angle right here because that's 90. So if you go 90 minus 36, that gives us 54. So J is 54. And lastly, we just got to find the hypotenuse K. All right, I'm going to still use angle L, all right, which is 36. So opposite is 8 over K. So that's sine. So I'm going to go right here. Sine of 36 equals opposite over hypotenuse, which is K. And if you multiply by K on both sides and divide by sine, you get K equals 8 divided by sine of 36. And doing so, we get 13.6. So K equals 13.6. Alright, right here, for number 3, it says, for each angle, find a coterminal angle such as negative 360 is less than theta, which is less than 360, or negative 2 pi is less than 2 pi. So 270, we got to find a coterminal angle to 270. So what we're going to do is we're going to do 270 plus 360. I'm going to do 270 minus 360. Alright. And in doing so, well, let me fix that plus. What we get is for one positive, and basically what this means is one positive, one negative. Alright. So one positive angle for 270 would be 630. And one negative angle would be negative 90. Make sure you understand that one of the answers have to be positive and the other one has to be negative, okay? Right here for 380, all right, we can find two coterminal angles. I'm going to do 360 minus, 380 minus 360 to get 20. And then I'm going to do I'm going to subtract that again. 20 minus 360. To get a negative 340, excuse me. So here's a positive coterminal angle because yes, this angle minus 360 is 20. So this is positive. I know it's smaller, but it's positive, guys. All right, and then this one right here is negative. Okay. For this one, 5 pi over 6, I'm going to use 2 pi. Well, you know 2 pi is equal to 360, guys. Alright, so 5 pi over 6. And also, let me mention, this is a radian. So my answer must be in radian. Alright. So I'm going to do 5 pi over 6 plus 2 pi. Well, I need common denominators, so if I make this a 6, I must multiply by 6 up here, which means 2 times 6 is 12 pi. So I have 5 plus 12, 17 pi over 6. So 17 pi over 6 is coterminal. That's my positive. And then for my negative, again, I'm going to end up with the same thing. All right, I'm going to subtract 12 pi over 6 this time. See, if I made that a 6 and that's a 6, that's still 12. So it'll be 5 minus 12, which is a negative 7 pi over 6. That's my negative. And then right here, this last one, 7 pi over 2. If we add 2 pi, well, we got to add the 2 to the top and bottom, so that's 4 pi. So that's 11 pi over 2. That's coterminal. And then for a negative, we're going to subtract 4 pi over 2, which will give us, nope, that's not big enough, because that's going to be 3 pi over 2. So that's still positive. So we got to find another one. So let's do it one more time. 3 pi over 2 minus 4 pi over 2. See, I use 4 pi over 2 again because that's 2 pi. 4 divided by 2 is 2. And that's going to be negative pi over 2. So there's my negative, and either one of those would be my positive. That's a positive, that's a positive, they're both acceptable. Alright, for this next example right here, convert each degree measure to radian measures, give an exact value, no decimals. Alright, so we need to convert these degrees. To convert this to a degree, you're going to multiply by 180 over pi, pi over 180. So we're going to multiply by times pi over 180. And what that gives us is 30 pi over 180, which we can reduce to pi over 6. Right here, negative 75 degrees, we're going to multiply again by pi over 180 to get negative 75 over 180. Negative 75 pi, excuse me, over 180. And when we reduce that, we get negative 5 pi over 12. All right. Right here, 230. We're going to multiply it again by pi over 180. And that gives us 23 pi over 18. And lastly, 125. We multiply by pi over 180. That gives us 25 pi over 36. All right. All right, again, right here, we're going to convert each radian measure to a degree, round the answers to the nearest 10th of a degree. All right. So to convert this to a degree, we multiply by 180 over pi. And what happens is the pi's cancel, and I have 180 over 9, which is 20 degrees. Right here, multiply by 180 over pi. All right, that is going to cancel out the pi's, which is 360 divided by 5, which is going to give us 72 degrees. Right here, 4 pi over 3, we multiply by 180 over pi. We have 720 over 3, which reduces to 240 degrees. And lastly, we have negative 7 pi over 2. Which is going to give us a 1,260, negative 1,260 divided by 2, which is a negative 630 degrees. All right, this next part here, it says find the value of x, round to the nearest 10th. All right, in this case, we have this angle 42 degrees. This is opposite. This is adjacent. This is the hypotenuse. All right, we are looking for x, which is the adjacent side. So given this angle 42 degrees, we have adjacent and hypotenuse. That identity is going to be cosine. So cosine of 42 equals adjacent over hypotenuse. So what we do is multiply by 18 on both sides. All right, and we have x equal to 18 cosine of 42 degrees. And that will give us 13.4. All right, x is 13.4. Over here, we got to find x. We have this angle here. This is opposite over hypotenuse, which that is going to be the sine function. So we have sine of 53 equal to opposite over hypotenuse. The hypotenuse is what we're looking for. So we multiply by x on both sides. And then divide by sine of 53 because we want x by itself. X equals 15 over sine of 23. Which is going to give us 38.4. 38.4. All right, right here, find the value of theta. All right, we got to find theta. All right, remember, you're going to use inverses when you're looking for theta. All right, so this side, if we have theta, this is opposite, this is adjacent, and then the longest side is always the hypotenuse. So what we have here is adjacent hypotenuse cosine. So cosine of theta equals adjacent over the hypotenuse. Oops, 10. Sorry, guys. 10. But we cannot find the cosine of theta. All right, what we got to do is use the inverse, all right, of cosine to isolate theta. And what we get is 53.1 degree. All right. And over here, theta, we have opposite, we have adjacent. So which trig identity would that be? Well, that's going to be tangent. Tangent of theta equals opposite over adjacent. And again, we take the inverse. And that equals theta, which is 14 degrees. So 53 degrees and 14 degrees. All right, next we have some word problems. And on this word problem, it says, in a water skiing competition, a jump ramp has the measurement shown to the nearest foot. What is the height, h, above the water that the skier leaves the ramp? All right, so again, we know what this angle is. It's 15.1. All right, and we have this side, h is opposite, and this side is the hypotenuse. So that identity, opposite and hypotenuse, is sine. So sine of 15.1 degrees equals opposite over hypotenuse. So now what we're going to do is we are going to multiply by 19 on both sides. So 19 sine of 15.1, oops, that's a terrible 5, equals h. All right. And that's going to be 4.94, which we round to the nearest tenth, which is 4.9. So 4.9 feet. 4.9 feet. All right, for this problem right here, we got to draw a triangle. And it says here, let me just get a triangle real quick. All right, right triangle. Well, it's all good. I don't need it. A biologist whose eye level is 6 feet above the ground measures the angle of elevation 6 feet above the ground. So let me do a rough little sketch here. I got a person. All right, 6 feet above the ground, measures the angle of elevation to the top of a tree to be 38.7 feet. So here's where he's looking. All right, and then the angle of elevation to the top of this tree is 38.7 degrees. If the biologist is standing 180 feet from the base of the tree, what is the height of the tree to the nearest foot? So we just got to find h. All right, got to find h. So with that being said, we have this here, the angle. This is adjacent, and this is the opposite. All right, I put h. I should have used opposite side. So we'll just say x because we're looking for the height. So adjacent and opposite would be tangent. So tangent of 38.7 equals opposite over hypotenuse, 180 feet, excuse me. So if I multiply by 180 on both sides, I end up with 180 times the tangent of 38.7. And that is going to give me 144.2 feet tall. for this next problem here, a pilot on a hot air balloon measures the angle of depression. Actually, I got to go back to this problem. We're not done. There's one thing we got to factor in. What I didn't do was I forgot about this portion. The man is 6 feet tall. There's his vision at 6 feet. So if that angle right there, or that height I measured of this portion of the tree is 144.2 feet, we've got to add in the additional 6 feet of where his vision is. So we end up with about 150.2 feet tall. The pilot of a hot air balloon measures the angle of depression to the landing spot of 20.5. So, hot air balloon. Alright, has an angle of depression. And you have to remember, guys, that's not the actual triangle itself. This angle right here is this angle of depression of 20.5. So real quick, we're going to do 90 minus 20.5, which is 69.5. So this angle right here is 69.5. We're going to use that. All right, at 20 points. So if the pilot's altitude is 90 meters, so that means he's 90 meters above, 90 meters up. What is the horizontal distance between the balloon and the landing spot? So here's the landing spot right here. So we have 90 up, and see, this is why you take the angle of depression. Remember, that's his vision. So the angle's formed here. That's not the actual triangle. All right. So anyway, we have the angle. We have hypotenuse. Oh wait, no, that's not hypotenuse. We have this side, which is opposite, and this is adjacent, which means that's tangent. So tangent of 69.5 equals opposite over 90. And so multiply by 90 on both sides. And that is going to give us 240.7 feet. Now, let's look at number 22. It says, find each trigonometric function value using even circle. Give exact answers, no decimals. So sine of 315, remember sine is x. Let me write this down for you so you have a reference as you work through these. Sine is x. I'm sorry. Cosine is x. Sine is y. Like that. So when I go sine of 315, that is going to give me negative square root of 2 over 2. All right. Tangent of negative 5 power 4. So for tangent of negative 5 power 4, we're going to look at the tangent of 3 power 4 because they're coterminal. And sine of 3 power 4 is radical 2 over 2, and cosine is negative radical 2 over 2. So what that gives us is radical 2 over 2 over radical 2 over 2, which is 1, but that has a negative attached, so negative 1. Cotangent of 510. 510 is equivalent, coterminal to 190 degrees. Ooh, I'm sorry. 510 is equivalent to 150. So we look at 150 degrees and we want cotangent of 150. Sine of cotangent, well, if you remember, cosine, is negative radical 3 over 2, and then sine is 1/2. All right, so we key change flip. to get negative radical 3 over 2 times 2 over 1. This gives us negative radical 3. Negative radical 3. Alright, for this problem here, secant of 3 pi over 2. Alright, so if you look at your unit circle, 3 pi over 2 is right here. And they want secant. Secant is 1 over x, and x is 0. So I'm going to do 1 over 0, which is, or 1 over x, is 1 over 0, which is undefined. For this one, cosecant of 17 pi over 6. But that's not on the unit circle. So what I need to do is find a coterminal angle to 17 pi over 6. No, I'm going to minus 2 pi because that's large. Minus 2 pi. That's 12. 17 minus 12 is going to give me 5 pi over 6. And again, 5 pi over 6 is right here on the unit circle. 5 pi over 6 right there. So we're doing cosecant, which is 1 over sine, or 1 over y. So we go 1 over 1/2. That equals 1 times 2 over 1, which is 2. Sorry about that. Now, this one, secant of 7 pi over 6, that is on the unit circle, and that is 1 over x. So in this case, we have 1 over negative 1/2. And I got that from the unit circle. So that's 1 times negative 2 over 1, which is negative 2. Let's keep going. Over here, cosine of 7 pi over 4. 7 pi over 4, cosine is the x value, which is square root of 2 over 2. That's on the unit circle. Cosine of 45 is x over y. And x is radical 2 over 2. And this is y is radical 2 over 2. And this over itself is 1. And finally, sine of 300, that's y. And y equals negative radical 3 over 2. That is from the unit circle. Alright. Now, number 37. Find the exact values of the 6 trig functions of theta, then find each on the terminal side of theta. Given each point on the terminal side of theta in a standard position. So this tells me I have a coordinate on a unit circle, coordinate plane, -3, up 2. So there is my triangle. There's theta. So I use Pythagorean Theorem. -2 squared is 4. 3 squared is 9. 4 plus 9 is going to be 13. Square root 13. So now I can find all my identities because I have all 3 sides of my triangle. So sine of theta is going to be opposite over hypotenuse, which we need to rationalize. Cosine of theta is going to be cosine of theta is going to be adjacent over hypotenuse, but you got to rationalize. Tangent is going to be opposite over adjacent. Cosecant is the inverse of this, so radical 13 over 2 secant is the inverse of this, negative radical 13 over 3. And then cotangent is equal to the inverse of this, negative 3 over 2. Alright, number 38. You do this the exact same way as the last problem. You figure out what quadrant that's in. So you have positive 4 and down, or actually positive 4 and down 2, which means there's your theta. And remember, your theta comes from the origin every single time. Alright? So now Pythagorean Theorem, negative 2 squared plus 4 squared equals c squared. That right there is 4 plus 16, that's 20. So c squared equals the square root of 20, which we take the square root on both sides. And then we rationalize this. The square root of 20 is the square root of 4 times the square root of 5, which equals 2 square root of 5. So that's the hypotenuse. So now you pick out your 6 identities. Alright, sine is going to be opposite over hypotenuse, except you got to rationalize that. So move the radical to the top. Keep the number from the radical at the bottom. But normally I would just multiply it. Ayo, chill out. But this time I'm just going to cancel out those 2's. So I end up with negative radical 5 over 5. You see that? Cosine will be 4 over 2 radical 5, which again you got to rationalize. And then if I reduce that, 4 divided by 2 is 2. So 2 radical 5 over 5, because that right there is 2 times 2. So one of the 2's will cancel out. So it's just 2 radical 5 over 5. That's cosine. Tangent will be opposite over adjacent, which is negative 1/2. So now we got to do cosecant, which is the inverse of sine. So I'm going to flip this one. Negative 2 radical 5 over 2, which that cancels out. So it's negative radical 5. Alright. Secant is the inverse of cosine, which again, I'm just going to flip. Well, no, I'll flip this one. 2 radical 5 over 4, which reduces 2 over 4 is 1/2. So radical 5 over 2. And then cotangent, excuse me, is the inverse of tangent, which is negative 1/2. So negative 2. Alright. I know it's all over the place, I'm sorry. Just running out of space and time. Alright, for this problem, let me zoom in. So my writing won't be as bad. For this one tells me that find the exact value of the indicated trig function of theta. Alright, and then alright, we're good. So sine right here is less than 0. So sine is less than 0, that means it's negative. And then right here, cosine is negative 12 over 13, which means cosine is negative. So what quadrant is negative negative? Well, that is the third quadrant. So now that I have a triangle, I'm going to say cosine is adjacent over hypotenuse. So negative 12, and it has to be negative, guys, because that's to the left of the origin, right? And then 13, my hypotenuse is always positive, so the negative has to be applied to one of them, negative 12 over 13. That's why my cosine is negative. And then Pythagorean Theorem, all right, you get 12 squared or negative 12 squared plus b squared equals 13 squared. That's 144 plus b squared equals 169. You subtract 44. 25, and then the square root, you get plus or minus 5. All right, plus or minus 5. So, guys, you got to go minus 5 because from the origin you went down. So this is negative 5. Now it says find tangent. Well, tangent, guys, of theta, we got to find one thing. Find tangent. Opposite over adjacent. Like that. And lastly, but not least, we have this problem right here. We have, let's see here. Secant, cosine is less than 0, so cosine is negative. And then cosine, that's cosecant, which is 1 over sine. And see how this is a positive 2, which means sine is positive. So I have a positive y, which means up, but a negative x. So negative x, positive y. So there's theta. And then cosecant is 1 over sine. All right, or in terms of a triangle, hypotenuse over opposite. All right, because this is 2 over 1, right? So hypotenuse over opposite. So opposite, hypotenuse, we got to find this right here. So 1 squared plus b squared equals 2 squared. 1 plus b squared equals 4. We get b squared equals 5. We get plus or minus 5. Plus or minus square root of 5. So negative square root of 5. Because see, now cosine is negative. Anyway, it says find secant of theta. Find secant of theta. So we have a triangle now. So we have adjacent. I'm sorry. You have hypotenuse over adjacent, which we rationalize. Don't forget your negative. And, oh, you know what? I just made a mistake. Man, I just made a mistake. Very simple mistake, though. I'm going to show you where I made a mistake. Right here. 4 minus 1 is 3. So you have the square root of 3 like that. So we got to rationalize it. Like that. Man, sorry about that. I'm rushing. I'm trying to leave. Alright, so there we go. Got a doctor's appointment. So those in my second period, you know that I had to dip out. So anyway, that's it, guys. That is really it. This is the video. I hope I will catch you tomorrow. Good luck on your quiz. Peace.